Okay, so that is how you would answer the Bell quiz questions. Who feels like you're all right with this? Raise your hands. Okay, that is by far the majority of people. Okay, the next ones, look, the next ones, they're not even hard. The hardest one really is gram to grams, meaning the longest. But you just did it and you're okay with it, right? So let's move to our notes. What page? Page 11, please. Take out your periodic tables and find the map. The map? All right. So I believe the first part of today is moles to liters. Now, anytime, you got to make sure you get this. Anytime I say moles to liters, I can also say liters to moles. It's the same process, just reversed. So looking at the map, if you would, or at the screen, if I give you moles, and you got to go to liters. If you didn't already, you need to put a liter right here and a liter right there. Okay, so I'm going to go from moles to liters, which means I go over, and then I got to go up. I prefer that you always cross right here in the middle. You could go up and over, but then your things are going to be misaligned. So go over and up. Now, every single one of you, you have your periodic table, and it has this little thing right here. If you need to write it out more clearly, because some of them aren't copied very well, that little ratio right there is 22.4 liters for every 1 mole. Does everyone see what I'm talking about? Now, this is a nice little thing because it's always the same number. So you don't have to add any parts. You don't have to think at all. If you're on that step, you just write 22.4 liters per mole. Okay? And then you got ratio of coefficients. We're used to that. That's moles and moles. So let's look. The first problem, I believe, in your homework, in your notes, it's C3H8 plus O2. Is that correct? Okay, see if you can balance that if you didn't already see the answers. Take about 1 minute. You can balance this, I promise. It is a combustion reaction. We'll make this the mascot of the recording today. What do you think?
Okay.
Here we go.
Isn't that just so interesting?
It's super interesting, especially.
I was so mad because I thought you were going to be able to see other things.
Yeah.
But you just saw one.
You're just looking at what it already is.
Do you know how bummed I was?
Way bummed.
I was eating cereal and I was like, yes, I get a toy.
Did your cereal get all salty from your tears? Does it fell in there?
I'm already salty.
Oh. Okay. Did anyone have 2, 10, 6, 8? Did anyone have 1, 5, 3, 4? We're just right here. You already did it forever. Oh, I'm sorry. In the example, water was first and carbon dioxide second, but it doesn't matter. Zeno, you need to focus. I have seen your quiz scores. Okay, here we go. Everybody, please stick with me. After I read this problem, it says, if you have 50 liters of oxygen, I'm good. I never wrote this. If you have 50 liters of oxygen, how many moles of C3H8 can you have? All right? So please look. Just go slow with me. It's giving you liters, and it's asking you to solve for what? Moles. Please look at the screen. I prefer that you go down and then over. You can go over and down, but I prefer down and over. That way it follows the picket fence better. So the first step says to use the liters per mole, and then the second one is ratio of coefficients. Are you with me? So it's not hard. We've done this 100 times already. What unit must come down here? Liters of O2. Well, how many liters of O2? 22.4. That number is always the same. Always the same. You all right with that? All right, now, anytime, I'm just looking at this thing right here. Anytime I write 22.4 liters, it's always attached to what else? 1 mole of the same thing. All right? If mole O2 is on top, what has to come down here? Mole of O2. And then what unit do I need at the end? Oops, H8, not H18. All right, no, you're fine. So this was a 2 from right there, and O2 was a 10. So now I'm going to reduce this to 1 over 5 just to save me a little bit of calculator work. So I'm going to take 50 and I'm going to divide it by 22.4 times 5. Be careful here. If you don't do your order of operations right, you'll get it wrong.
Wait, I thought it was point.
What?
It's point 4.
This is where I got the 5. Did I say 5 twice? I probably did. Point 4-ish?
Mm-hmm.
Point 4-ish. All right. When you type that in, did you get point 4? Please raise your hands if you got point 4. If you got a different number, you didn't type it in right. Point 4. Okay. Please, we've repeated the exact same process for a week now. You take what I give you and you get rid of it by putting it on the bottom. It's tied to something. You get rid of that by putting that on the bottom, and it's tied to something. You get rid of that. And then usually, you just keep on going until you get your answer. Please look at the screen for a second. Every single one of these, the whole reason for the picket fence is to get rid of the units I don't want until I get the ones that I do. Ready? Uh-oh. Don't do this to me. Maybe. Hold on. All right. So if you'll notice, liters of O2 cancels out. Moles of O2 cancel out. This doesn't have anything to cancel it out, but that's okay because that's what I wanted my answer. If I go back, look right here. Grams Cl2 cancels out. I never wrote this. This was 71. Moles Cl2 canceled out. Mole NaCl. Mole NaCl. I was left with grams of NaCl. Wow, how lazy was I last time? Whoops, that doesn't cancel out. I'm going to fail myself. But we're just lining it up to make things cancel out. Let's do this one. Turn to your homework. This is problem number something, 46. Let's skip one. 47. Which means I expect you to do 46 on your own. But look at number 47. This one, the only hard part is sometimes the chemical equation. It says I don't even know. Sulfuric acid is formed, acid rain essentially with water, and sulfur trioxide hook up. So look at the screen. I've already written it for you. SO3 plus H2O goes to H2SO4. I will also tell you, if you keep looking at the screen, this is already balanced. It gave you liters. It's asking for moles of something. See if you can figure it out. It takes about 2 or 3 minutes. So hopefully you're realizing that this is just a process that you keep following over and over and over. I wrote a little song for it. It's called Follow the Process. If you follow the process, follow the process, follow the process, and you won't get it wrong. Okay, now, look, liters. If liters is up here, where do they go? Down there. And every single time I write liters in a picket fence, it should be what? 22.4 liters of the same thing, SO3, per every 1 mole SO3, whatever. They have to match. Don't ever switch your identity inside of that. The only time you can do that is moles over moles. All right, if mole SO3 is up here, what's down here? And what's in front of SO3? A 1. And the top here is mole of what I want. What do I want? H2SO4, that's a 1. So 35 divided by 22.4 is 1 point something. 1.4? 1.5?
1.6. Well, if you round up, then it's
1.6.
So you want us to round?
I don't care.
Okay.
Just don't give me an answer that long. Okay, who had 1.6? Okay, then do the one above without any of my help.
Wait, so like if there were 2 here and a 4 here, would you put a 2 here?
Warn you this time. Okay, so point 2, very logical process. You have liters, so you get rid of them by putting them down low. They're tied to moles. Moles, there's your mole O2. Okay, now, back to your notes. Now look, every one of these homework problems that I don't do in class with you, you still need to do. Kids this trimester had a bad habit of not doing any homework because I guess I didn't directly tell them to do it. So listen to me. Every single problem in your homework is assigned. Your homework started on page number 12, probably. Yep.
No, I thought. Oh.
It does.
You have to move the type of reactions.
The type of reactions we've gone over, so we should have that. The only thing we haven't gone over yet is like the note pages and then these last 2 math ones. The notes on reactions. They're not hard. Okay, look. This next step is called liters to grams or grams to liters. So look at the map. If I'm going liters to grams, I would do the following. You with me? I would start at liters. I would go down, over, and over. If I was starting grams and liters, please look, I would go over, over, up. Okay? That's all I'm going to do. It's what we just did, except for one more step. But I really think you're getting it. So let's just do the first one. Tell me what the chemistry is, somebody.
If 23 pounds of lithium are reacted, how many liters of oxygen must be used to complete the reaction?
Whoa.
Are we on the notes?
Yeah, I think.
So Li plus O2 equals Li.
Is it liters of O2, right?
Yeah. How many liters
Okay.
of oxygen?
So here we go. The first thing would be to balance the reaction. It's already written for you. You should already probably have it balanced. Li plus O2 goes to Li2O.
Oh,
So double that, 4 that, 1 that. 4, 1, 2. Okay, now I'm going to picket fence it. Can somebody tell me how many vertical lines I'm going to put?
3.
3, because I'm going over 3 arrows. So 1, 2, 3. All right, I'm going to start with 23 grams of Li. And then we're off to the races. So for every gram, or sorry, if anything's on top, I always write it per, oh, shut up, Tom. Whatever's on top goes on the bottom of the next one, right?
Yeah.
So I have grams of Li, and then what I was meaning to say. Anytime I write grams, it's what? 1 mole of Li. I'll come back and fill that number in a minute. What must go down here? Moles of Li. Now, this is one where I would start at the other end now and work my way back. Did I lose you, Bailey? Okay. I'm solving for liters of what? O2, which means what has to go here? Liters of O2. Anytime I write that, it's 22.4 for every what? 1 mole of the exact same thing, so O2. So now what goes up there? Mole O2. Now I just look up. In front of O2 was a 1. In front of Li was a 4. And then what's in front of GLI? 7. Does everybody know where I got the 7 from? The 7's from the mass. It's 6.9 up there, but it's 7 we round to. Okay, 23 times 24 divided by 14. I mean 28. Well, that was a little bit harder for me to do in my head. Hold on. I'm going to say 28 point something. No? What is it?
18.4. So you had the right.
What?
It's 18.4.
Well, I know what I did wrong. Like, I am pretty good at estimating in my head, but that time I knew it was close to 22.4, but I went high instead of low, and I should have gone low.
18.
18 point what? Okay, be honest, who thinks this is not very hard anymore? Oh, well, poop. I was hoping like 20 of you would raise your hand. Only 16 did. Okay. Homework time. So let's do number, finally on the back page. Let's do number something hard.
Yeah, do 50.
None of them are hard.
You gave us
50.
no room on 51.
Okay, 50 it is. I'm sorry about no room on 51. Okay, number 50. No. 50 says water breaks apart, right? So H2O goes to H2 plus O2. Look good? Now, yada, 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 I don't care. 150 grams of water. And what's it asking you to solve for? Uh-oh. Oh.
How many liters of hydrogen gas can we use?
Okay, liters of hydrogen gas. Okay, have fun. First one to get it right gets props, because that's all I have to give. Quick, and then we'll show you one last trick. So we had 18 grams H2O. Grams is always attached to 1 mole of the same thing. So what has to come down here? Mole of H2O. There's a 2 in front of that. Man, no one's paying attention, so that must mean you got it.
Wait. So, for the 2, did you put them right here?
I got it from right there.
Okay.
Okay, then, liters of H2, so 22.4 liters of H2. Liters is always attached to 1 mole. H2, what must go up there then? Mole of H2, it's frozen. What's in front of it? Oh, there, maybe.
So it'd be 1.
So 2 mole. Gosh, no, it's down.
And then you have 9 oxygen.
Okay. By the amount of talking, I'll assume that everyone knows how to do those perfectly. Okay, we have one last one to do. All right. So turn back to your notes. Does it make sense? Okay, fine. I won't do it. I'm going to come back here. Okay, please look. The last thing we're going to do is go from liters to liters. Now, I'm going to show you the super long way, and then I'll show you the very easy way. The long way, you go down, over, and up. How many steps is that? That's 3. 1, 2, 3. Then, we'll do it that way, and then I'll show you that we can go straight across. But the straight across, you have to be a little bit careful or you'll write the wrong unit. So here we go. So this is liters to liters. It's not hard. First off, balance the equation. Is it that one again?
S plus O2.
Oh, it's SO3 though. Thank you. So I get 232. Is that what you have? I'm on the bottom of page 11. Now, if you have 12, thank you, 12 liters of O2, and it wants liters of what? Okay, here we go. We still do everything exactly the same. What's my starter? 12 liters of O2, so what has to go on the bottom? Liters of O2. What always goes in front of liters? 22.4. And liters is always per what? 1 mole of the same thing. If I have mole O2 on the top, I need mole O2 on the bottom. What was in front of mole O2? A 3. I got that from my, I almost say graduated cylinder, my balanced chemical reaction. Then I'm going to go to the end. It wants me to solve for liters SO3, which means what? So that's going to be 22.4 again. Anytime I write liters, it's per what? 1 mole, SO3, and if mole, SO3 is here, it has to be up there, and it's a 2. Now, look carefully. Please look at the screen for a second. Mathematically, these two steps are reciprocals of each other, are they not? So, mathematically, we don't need to do them. Why do we do them? It's so the picket fence works out. And by the way, the picket fence is just a way to keep track of your units. So it's a way that your units work out. But really, all I did is take 12 times 2 and divide it by 3. I can finally do that in my head. That's 8 liters, right? So please look, and please stick with me. Going straight across right here was that step right there, which is the only one mathematically that matters. So please, if you like it, take the shortcut. The only danger of the shortcut is that you might write the wrong units, and you might put your coefficients upside down. So just make sure that your O2, or whatever your given is always on the bottom, and whatever your wanted is always on the top. Now listen, 50% of kids don't understand the shortcut. So don't take it. You've been with me till now. Just do it the long way and you'll be fine. Let's do one from your homework as fast as we can. So this one's not hard. We got N2 plus O2 goes to nitrogen monoxide. I guess I should read it. We already did this one, like chemically. So there's a big fat 2 right there, a 1, and a 1. Do you want me to do it the long way or the short way?
Long.
Short.
I'll do it both. Hold on. Oh, I skipped 52, didn't I? Oh, well. So I'm given 18 liters. Okay. Screw it. Oh, my heaven's sakes, Thomas Davidson. 8 liters of O2, and I'm asked for liters of NO. Okay, I'll do it the long way and the short way. You do it whatever way you feel like, and then look up. Straight until I let go. That's 18. Thank you. Is that right? Yeah. Hey, let me just help you on 52. Actually, Ashley's going to read you out the coefficients right now. We did them together.
Oh,
I don't remember what they are.
oh my God.
Actually, I do. 2, 12, 12, 12. Right? No? 1, 6, 6, 6?
No, it's 2, 12, 12. That's what you got.
Trust me. 1, 12, 12, 12. The reason why is because sugars are the devil, right?
Wait, 1, 12, 12.
1, 6, 6, 6.
So it's 1, 12, 12, 12.
Yeah, or,
Would it be easier?
sorry, it's 2, 12, 12, 12, or 1, 6, 6, 6. Sorry.
So we like counted
36
6,
minus
so we
6 instead
didn't
of
count
12. Hey, listen. All the math now is doable, and hopefully you have it pretty much done. Do some tonight if you haven't, please second. Tomorrow we review. Thursday we test. It's just fog.
I hate
Sorry.